So, okay, in this video, we will do this question, container with most water. This is a medium level of question, and here what you have to do. So, let me read it. You are given an integer array height of length n. There are n vertical lines drawn such that the two endpoints of ith line are I comma 0 and I comma height of I. So, see what it is trying to say to us. So, see, this is your input array. This is height array. That's what it was saying. That's what the question saying. Height array and it has n. Its length is n. See what is this in 3, 3, 6 and 3, 9. So see there are 9 bars inside this graph. Yes, there are 9 bars and these are not a bar. These are containers of different height and the water will be stored between them. Okay, so you have to do something like this and see two endpoints of ith line are I comma 0. Okay, so see this point is I comma 0. This bottom point and this is I comma height of I. Height of I is what 8. So I is 1 here. So 1 comma 8, its height is 1 comma 8, such something like this we have to do. So okay, we will do this and you have to return maximum amount of water contain a water a container can store. Okay, so we will return this. So see in this question, if you see the maximum amount of water that can be stored inside this container is this much, and it is 49. Why it is 49? The see this explanation. The above vertical lines are represented by array. This in this case the max area blue section can contain. See this max area can be, this is height of 7 and see this rectangle, area of this rectangle will be what, this is height of 7 and if you see this 0 1 2 3 4 5 6 7 8, this is eighth eighth container and this is 0 1, this is first container. 8 minus 1 is what, 7. So 7 into 7 is 49. So I will explain it to you here. So see this, uh, let me do this and see I'm doing indexing right now. So this is of 0th index. Okay, and this is of 1th index. Okay, wait, sorry, and this is of uh, second index. Yes, 0 1 2 3 4 and 5 5. This is 6 and this is 7 and this is 8. So okay, I know I will do something like this. uh, I'll make them here and 6 7 and this is of 8th index. Yes, and what was our array? Our array was this was our array. So see, I'm making that array also. I'm pasting it here. So can I stretch this array? Yes, we can do something like this, but it is not coming like this direction. Okay, so something like this, our array will be like this. uh, I'm trying to do my best, but let me see, can I do or not? So okay, so yeah, we did that. So now I will do what? See, uh, let me stretch it to some more extent. So see, can I do this? Yes, I can. Again, uh, I'm stretching this 7 also. Yes. So see this. This is my array. Okay, and if you see here, uh, yes, if you see here, so see, this time we have this is 0th one of height. The bar of height 1 is at 0th index. Yes, the bar of height 1 is at 0th index. See this bar of height 1, its height is 1 and it is at 0th index. Bar its height is 8. See this, its height is 8 and it is at first index. Its height is 6. Its height is 6. Yes, see this is 6 and it is at second index. And how can we see that how much water will be stored inside it? So this is a problem. This is the basic task. If you know this, you can do this question very easily. This is not that tough question. So see, if I want to know how much water between store will be stored between these two bars. Suppose these are my two bars and its length is suppose 6 and its length is 8 and distance between them, let's say it's 2. Okay, so how can I say that? See, the most water that can be stored in this bar is this much only, because if you go if you take your water here in this level, it will spill out from this. See, because here no wall is there. So if you make your water more than this 6 height, so it will spill out, and this water will be spilled out from this conductor, or this container. So okay, so means we can only get our maximum height 6 only. Okay, and breadth is 2, width. So 6 twos are 12. So the area of this container will be 12. The maximum water that can be stored inside this container is of 12 area. Okay, so see, I'm taking example from this graph only. See these bar. You might be thinking that they will be storing the most area, but see, they are not. Why? Because see, they are of equal height, so we'll take their height only. But how much water, maximum water they can store? Let's see. Their height is 8. Height is what? 8. And their width is what? 6 minus 1. It is 5. So if I do 8, height is 8, and their width is what? Width is what? 5. 6 minus 1. Yes. So 8 fives are 40. So this is not the maximum area. So let me write area formula is first. So area is equals to L uh, cross B. Yes, length into breadth, or length into width. Yes. So see, they have given us that max area will be this. The this will be maximum area. So now how can we say that? We haven't checked it right now till now. So let me check it. So see, its length is 8, and see, its length is not, yes, its length is 7. See, height of last container is 7, and its index is 8. Okay, and height of this container is 8, and its index is 1. So what is this width? Width between them is 8 minus 1. 8 minus 1. So 8 minus, so what will be the width? Let me see what will be the width. 8 minus 1, so this will be 7. Yes, so our width will be 7, and maximum height is what? If you compare these two red containers, maximum height is 7 only. So max height is 7. So 7 into, so our length is 7, and if I do 7 into width is equals to 49. 49, sorry, but not 47, 49. So that's what our answer was. So there are two approaches to this question. We can apply brute force. We will take this one, okay, and we will take this 0. So see, container started filling from this portion only, so we'll take this one. Okay, so this 8th height, and we will check, or we will take this one, and we will check which of one from this 8 to 7 are making the greatest area with this one. Okay, and then we will take this 8, and then we will check which of the following in this is making the greatest area. Then we will take this as I, and J will be iterating through this, and we will check which one of them is making greatest area, and then we will store that area, into a max, or in any other value. I can do that brute force approach code also, but here I will tell you the code of two pointer. So how will two pointer work here? I will make my first pointer to here I, and my last pointer to here J. Yes, so I will check area between them. So last container is at 7th height, 7th, and its index is 8. See, its index is 8. So I know this. Last container is of 7 height, and its index is 8. And the first container is of 1 height, and its index is 0. So how much area will be, area between them is what? 7. First, I will do which height is minimum. So this is minimum. Okay, and width between them is 8 minus 0. See this, 8 minus this 0. So width between them is 8. So 8 is the width into length, into length is what? 1. We'll take the minimum length. So 8 into 1 is what? 8. So we got our area now. But now how will I increase my pointer? So see, we got this, but see this. Suppose we get a bigger bar after this one, then what? Suppose if we are getting a smaller bar after this one, we will move R1, we will not move this I. But if we get a bigger bar after this, we'll move this, because why? If I move it to bigger, there are chances that our area will increase. Yes, there are high chances that our area will increase. But if I move, see, suppose my I is here, I'm telling you, wait, I is here, okay, and my J is, wait, J is here, okay, why can't I draw some, my J, okay, I'm moving this J to here. Suppose my J is here and I is here. Okay, so if see, here our I was this. I have a bigger bar after this I. So I'll move this I. There are chances that our area will increase because if bar length into breadth, it's length into breadth. If you increase, see, breadth will always decrease. If you go like this, breadth will decrease. This distance between them is decreasing. Yes. Okay. And if you go like this, your breadth will also decrease. So breadth cannot increase area, but length can increase area. Yes. There are chances that length will remain, if length is greater, the area will remain same. See, if this length increases and this breadth decreases, there are chances that area will remain constant. Or if this length increases so much and breadth increases a little, decreases a little, so then our chances that area will increase. So like this. So we got a see we got a bigger bar here, so I moved my I. Now I will check area between them, that is 49. We already calculated that. So there is smaller bar after that. So uh, shall I? Okay, so what is this? I don't want this arrow. So okay, I don't want this arrow. Yes. So see, I got a bigger bar. I moved it, and see, that's my biggest area. So that's what our problem is. So let us do it. So else see, if else we can do j minus minus, it won't affect our solution. But again, if I move j to a smaller height, there are chances that area will decrease. So we will not do that. But yes, let's do it. So let uh, so let uh, max height. Yes, and I'm changing this height to ARR. ARR. Okay. So what will be our max height? So let's see. First, I will make my pointers. First, I should make my pointer at I comma j. So let I is equals to 0, and let j is equals to ARR dot length minus 1. Yes, this will be our j pointer. J will be at 8th position. So what is my length, minimum length? So uh, while I will apply a loop here, and inside that loop I have not written condition right now, or I can write just like this: I less than j, till I less than j, do this. And while I is less than j, okay. And now I will check area between them. So for that I have to calculate which is the smaller. So let len is equals to math dot min arr of I comma j. Which one is minimum between them? I comma j. Which was minimum? Take that. And let uh, width, let width is equals to what? J minus I. Yes, j minus I will always be our width. See this, 8 minus 0 was our first width, then 8 minus 1. So like this. So and let area is equals to len into d dth. Oh, yes. So length into width. This is our area. So now we got our area. Suppose now if uh, area is equals to, okay. So we'll make area here. Let area is equals to 0. Why? Because we'll store maximum area in it. So I'll do something like this. Area is equals to math dot max from initial area that we have, comma the area now we calculated, comma len into see this. I'll do something like this. And if see, if I less than I plus 1, not arr of arr of I uh, less than from I plus 1. So I'll move this arr of I plus 1. I'll move my I pointer, I plus plus. Else I'll move. I can move my j pointer as well. Else move j pointer, j minus minus. Both are a good solution. So and if we got, I will return area. Return my area. Return my area. Okay. So yeah, our solution is good. And if I run it, let me see, will I get the right output? So see, we are getting right. And if I run it, this code will be submitted. So see, let me error. So okay, we are getting an error. Height was 361. So see, this height was 361. So 3, 6, and 1. Okay, it was like this. And 0, 1, 2. This is 3. This is 6. This is 1. I have drawn it. Uh, okay. So first we will calculate area between them. So okay, and we will store it to max. And then if our I will increase my I. Okay. So if I increase my J, see, 3 into 1 is more than this 2 into 1. So this time I should decrease my J. Okay. If J minus 1 greater than or see which one in I and J is greater. If array of I is greater than is less than array of J. Array of I was 3. Is it less than J? No. Then don't move I. Uh, else move I plus plus. Which wall is smaller? We will move that pointer. J minus minus. If I is less than J, uh, I is greater than J, then move J only. I greater than J, then to move J. Else uh, I plus plus. If I greater than J, yes, move J. Else I plus plus. So let me use this test case and let me see, will this give me right output or not. Greater than J. I'm doing it right, but okay. Now I'm sure that this should run. And if I is greater than J, then I am moving my J pointer. Okay. So okay, so now our solution is accepted, and thank you so much. This was my solution for this question, and you'll find many solution, but I think this is the best approach because brute force will give us O of n square, and now we are calculating it O of n. So that is a good time complexity. So thank you so much.